2022 on Analogies, Modelling and Outdoor Learning. I'm Martin Crawshaw and I'm at Melbourne Academy in Inverness. So this is a couple of what we might call models of the Bohr model of the atom. Neither are very accurate, as we're well aware, and both can cause controversy both in the classroom and amongst colleagues. So we'll come back to ideas like this in just a moment. First, I'd like to put in terms of reference in terms of what this talk refers to as an analogy. So that's comparison between a concept in physics and something which is more familiar to the learners. Modeling is a physical or concrete model or an artifact or activity to demonstrate physical concepts. And finally, outdoor learning, anything that we can do outdoors which allows investigation or exploration of physics. We did a Jamboard, which I'll put the link to. You can have a look on there on that last slide. But in terms of analogies, these are the ones I'm going to consider. This screencast is going to move quite quickly because the links to all these slides are given in the comments of the video, and it's best that you open up the slides yourself and have a run through for any links. Everything that's on here is linked, including this YouTube video, which is one of the most kind of controversial analogies between electric current and water. And the consensus of discussion in the on the evening was that nobody uses water in high school as a analogy for electric current. There's just too many misconceptions that can get incurred by doing it. But it's interesting to watch the YouTube clip to see some of the ways that it could be described. Parallel circuits, going on from that, you could consider people at turnstiles of a football match as being a parallel circuit. The turnstiles are resistance. They slow people down. Again, the word slow as opposed to resist the people coming in, but the more turnstiles are open, the more people can get in. Fraction in terms of wave speed is a great one, and this is some animators take on the marching band analogy, going into different media of slowing the band down. Again, I would encourage you to have a look at that video there, but it doesn't work so well on the screencast. And this is an open-end question where a car is slowing down on one side, and therefore does it really refract as it goes into the sand? And I think quite a difficult one for pupils to actually draw a correct analogy with wave speed on that. Another imperfect analogy is the idea of a fence for plane polarization of electromagnetic waves. It kind of works for cross polarizers, but it certainly doesn't work for the Dirac 3 polarizer. And you can see the quote there from one of the references that I had mentioned earlier. And then it really falls down when you consider the jail bars experiment, where you've got vertical conductors, which soaks up the electrical component and does the complete opposite of what the analogy might expect. In terms of the expanding universe, a balloon is often used as an expansion analogy, but really it's much more complicated as that, as we know, in terms of expansion of space-time, and therefore the two-dimensional surface of the model of the balloon isn't really inaccurate, and therefore I think we have to discuss this with students as to what works and what doesn't. The idea of photoelectric effect and a coconut shy, I think this one took a lot of people by surprise in 2015 here, and so there's some points there, and again the discussion on the night was that this doesn't really work as an analogy, but it's useful as an open-ended question. Similar is car parks and capacitance, another higher open-ended question. This time, is the capacitor like cars trying to enter a car park, and they've got a speed bump there as resistance, and quite difficult. Does it really give a full picture of capacitance and charging? Finally, looking at just using previous learning to build on and draw an analogy between, for instance, speed-time graphs and energy stored under a capacitor. They're both energy under a graph. They've both got variation, direct proportion between the two variables. If you teach advanced higher, the helical motion of a charged particle in magnetic field is analogous to a projectile. Both have constant velocity constant speed in one direction, and the other component causing acceleration. And finally, again, for advanced higher, comparison between electrical and gravitational fields can be helpful. Moving on now to modeling. So that's the ones that we'll be going through. And you will be familiar with using ball bearing or ping pong ball models. So again, there's a video clip there which is worth looking at there. In terms of cyclotrons, there's a great video here from Berkeley University, and that's also a open-ended question on that. And you can make your own solid ball particle accelerator with a couple of either high tension supplies or a Van de Graaff generator, and there's instructions given there if you fancy trying that. And there is a YouTube video to go on a little bit further there. A classic analogy is that of space-time with a lycra or latex sheet here, and the latex sheet is to act as bent space-time with a gravitational object and other objects in space-time moving around that. So again, a classic demonstration there. Chain reaction or radioactive decay. I'll set the video watching for this because it's worth watching. And the tumbling dice analogy for radioactive decay. There's other videos with mouse traps and things like that. A really successful model which gives quantitative results is simulating redshift or expanding universe with elastic bands and steel washers, and that's described in the Perimeter Institute from the links that are given there. Rope as an electric current is one that's done the rounds in Scotland, certainly. Stuart Farmer's a big fan of this and described it on the evening, but this is just a video which talks about it briefly as well. Having alpha particles for closest approach, the idea that the kinetic energy converts into the potential energy at closest approach can be done with magnets and polystyrene beads quite successfully. And one which I've considered but never quite got to hang of is using cardboard with weights as electrons and holes in the valence band and conduction band. Works really well with conduction with holes and electrons, but I'm less convinced of it as a good model of doped p-n junction diodes. Finally, pool ball reflection is a big no-no. This is a video on a website that does use it, but I don't think any of us, even with wave particle duality, would use snooker balls as a model of reflection. Of course, don't forget that there's a lot of digital simulations, and Helen Reynolds' website there, sorry, the spreadsheet she's got lists literally hundreds and thousands of different simulations or video clips that you could use as well as physical models. Moving on finally to outdoor learning. So I'm not going to go through each of these, but there's a list there of other things that you could want to try out. Rockets, air rockets, pyrotechnic rockets, water rockets, they're all really good crowd pleasers and obviously best done outside. You can record that motion using motion analysis tools and Vernier motion analysis for iOS. Slight cost, but works very well. Allows you to get components of projectiles or rocket motion really well. Measuring average speed can be done quite effectively just outside the school grounds, but you can keep the pupils within, minimizing your risk assessment, just total distance over total time, but really good active learning. In terms of higher impulse momentum, egg drop challenge is a good way of can you maximize the time, minimize the force. That could be done better outside through an open window. In terms of measuring the speed of sound, it is possible if you've got a school grounds that's got at least 300 meters of distance, and you can introduce the idea of a sound second of distance, which is the distance sound travels in 1 second, which can then lead on to light years as a unit of distance. This is a homemade clapperboard with 2 flags, so you can see the movement and then actually hear quite an effective clap over 300 meters. Comparing falling objects, in the sort of Galileo, all things accelerate at the same rate, works really well if everybody lets go at the same time, which they generally don't. Doppler effect can be done quite well outside here. So this is a Bluetooth speaker operated from a phone as a signal generator, and then either using Firefox to do that there. So you can hear the sound if you play back the slides and the link on the slides there. Another good experiment to do outside is investigating central force using a rubber bung on a glass tube there. There's full instructions given on that link there. Again, safer to do it outside than certainly in a classroom or even in an indoor space. This is actually Chad Ordsall of How to Teach Your Dog Quantum Physics fame, demonstrating conservation of angular momentum quite nicely, and really good to do with seniors, but the risk assessment is probably going well beyond what you'd feel comfortable with accompanying pupils, but you can ask them to have a go themselves at the play park. Going back to using video capture, linear video can be used for damped simple harmonic motion really well. It works really well on iPads, but not so good on smaller phones. Using a CD case and a mug or cup to demonstrate air pressure is great fun, where the mug contains water. You turn the thing upside down. As you can see, the class has great fun. You can drive your minibus and record speed if you've got a capable passenger, and then video that whole thing. I've used picture-in-picture editing on iMovie, and then you can play that back in class, and class can plot their own speed time graph. So that video there is available if you did want to try that. Really, anything that you're not needing mains for can be done outside. So I'd encourage you to sometimes, especially if it's a nice day or if class needs a bit of a break from indoor learning, just take them outside. And if the weather's good enough, just see what you get up to. So overall, we saw outdoor learning and all these sort of ways of putting concepts across as being good in terms of active learning, promoting discussion, including critical thinking, but it could increase the cognitive load. It gives them a lot more to think about, and for some pupils it actually confuses them more than it did in the first place, and you can actually lose the physics in the fun of being outside. So I hope that's been useful to you, and that you can try some of those things out in your class, or let me know in the comments if you've tried anything or you've got any other ideas. Finally, there's some recommended reading from Marianne van Nielhuis, who attended the session from the Netherlands.